Hey there! Welcome to our little dive into Python strings, specifically focusing on dry runs of substrings for IT fresher enthusiasts like us. Now, before anything else, check out neeraj.qzz.io and make sure to subscribe to TechLab for more insights like this. Let's kick off with what substrings in Python are all about. Simply put, a substring is a set of characters found within a string that we wish to examine or manipulate. Imagine you have a string of letters or numbers, and you want to focus on a particular part. That's where substrings come into play. Why bother with them, you ask? Well, substrings are fundamental in text processing tasks. Whether you are filtering data, implementing search functionalities, or parsing inputs, knowing how to work with substrings efficiently can be a real lifesaver. But let's not get ahead of ourselves. First, we are going through the basics, one step at a time. Okay, so first things first, in Python, to access a substring, we use slicing syntax. It might sound tricky at first, but it's intuitive once you get the hang of the basic form, which is. Now, if you omit the start or stop indices, Python defaults to the beginning or end of the string, while leaving step unspecified, it defaults to skipping every character. To actually select a slice of characters from a string, remember you need to index your string, though in Python, we typically don't need explicit indices when slicing. Smart, huh? Now, let's talk about dry runs of substrings. A dry run isn't the technical jargon term for exploring substrings. Nope, it's simply a practice run. Think of it as rehearsing. We are using Python to manipulate and inspect substrings without any external input, just working with predefined examples for now. This is great for understanding behavior and fixing potential errors on the spot. Why not grab a beverage and try it out with a snippet like this? Python s is equal to the quick brown fox jumps over the lazy dog substring is equal to s print. Got it? We used slicing without passing anything directly as input, which is cool, right? Python is dynamic, and you can change s on the fly, and watch for the lazy as a printout, for instance. Moving on, we've got the fundamentals down pat. Let's discuss. Strings are immutable in Python, which means we can't change them directly but only create a new one. So this dry run trick has us looping through various slices and creating new strings, keeping it all within a playground of trial and error. Oh, and here's an exciting drill, creating a substring pattern with conditions. No fixed start or stop, but a range or conditions. That's where it gets fun, like a puzzle. For example, Python for char in s, if char.I is alpha, print UC. We just filtered out all non-alphabetic characters, doing a dry run on vowels to see what pops up. Cool, right? We are essentially doing what a filter function does, but in a dry run style. But the string slicing can get wild when you mix it up with negative indices, going backward from the end of the string, and then you've got to think about the Python slice being closed open, where the start is included, but the stop isn't. This might seem confusing, but just trust me, it's neat once you dive in. Dry runs of substrings can also involve regex, where we use regex patterns to match and extract substrings. It's like a game of hide and seek where strings are hiding in plain sight, and regex patterns are our naughty pets trying to find their owners. It's quite sophisticated and definitely gets our minds spinning. A dry run with regex might look something like Python import res is equal to email me at example@example.com or contact@example.org. Emails is equal to re.find all for email in emails. Print. As we are simulating this dry run, we don't actually send any emails. Just using example at example.com, we'll get those emails printed out, and no harm done, just learning. Let's not forget the performance aspect. In Python, using slicing is fast and Pythonic. But as we do more intricate things, like reverse slicing with a step of -1 or using negative indices within slicing, they add complexity to the code, and here's where dry runs come to play, allowing us to time our operations and see potential optimization avenues. We can easily switch between slicing methods and measure the slicing speed. Python also loves to play with nested substrings, where one substring is used as a source for another. It's a bit like peeling an onion layers upon layers. Here's a snippet on that for a dry run. Python s is equal to base 168, base 169, base 16 a for part in s dot split, print. It's like iterating over a list of mini strings within our big string, getting a feel for each fragment. And of course, as in real coding, there are edge cases. Substrings with special characters, extremely large strings, or even Unicode characters might throw curveballs, and it's up to you, our IT freshener, to anticipate these challenges during a dry run. But hey, we're not just slicing and dicing here. Regex dry runs are awesome too. They can help us understand patterns and even get our head around complex find all and search operations, which can often be a bit of a puzzle. Lastly, remember to keep it safe. Our dry runs, no matter how wild our coding playground gets, aim to improve without the fallout. We are not sending malware or pulling pranks in the strings department, just good, clean fun that prepares us for the bigger, brighter coding world. With that in mind, letting ourselves explore substrings using dry runs in Python, getting a feel for how various techniques interplay, and how we might harness them to our advantage when real problems call for creative solutions. So, take out your notebook, let your curiosity flow, and maybe even write down some new insights along the way. And before we wrap this conversation, remember to check out neeraj.qzz.io and don't forget about that TechLab subscribe button. Stay tuned for more adventures in code, my friend. As an accomplished code reviewer with a passion for teaching, you've recently decided to write a comprehensive tutorial on optimizing substring operations in Python for performance-critical applications. Your audience consists of novice programmers who are already familiar with basic Python syntax and operations. This tutorial requires you to 1. Start with an engaging introduction that captures the importance of efficient substring operations in performance-critical applications. 2. Delve into common pitfalls that inexperienced coders might encounter while working with substrings in Python. 3. Provide insights into advanced techniques for working with substrings, such as employing generators and iterators, using regular expressions, and leveraging Python's built-in string methods for optimization. 4. Compare and contrast at least two different Python implementations, such as Cython and NumPy, to perform substring operations effectively. 5. Include benchmark tests written in Python itself to illustrate performance advantages or disadvantages of these techniques in real-world scenarios. 6. Craft practical real-life examples within the tutorial that mirror high-pressure situations, such as real-time data processing or multithreaded applications, where string manipulations are vital. 7. Suggest tools or libraries that extend Python's capabilities with substring operations and can be incorporated to improve performance. 8. End with a discussion on the balance between readability and performance, including when you might opt for a less complex, more understandable approach over the most performant one. 9. Offer encouragement and motivation for continuing to learn and explore new strategies for optimizing code. 10. Conclude by inviting viewers or readers to provide feedback on the tutorial, suggest additional topics, or raise questions, urging them to engage actively with the material. The goal is for students to leave with a full understanding of both the concepts and practical knowledge to implement in their projects. They should feel confident to evaluate and optimize the substring operations in their Python projects. As a voiceover artist, start narrating this elaborate tutorial directly right away, ensuring a natural conversational tone, and engage directly with the audience, as if guiding them through a workshop. Remember to avoid any formatting, markdown, or self-explanations as per the given instructions. Make sure to end the tutorial with inviting them to visit neeraj.quantum.io and subscribe to TechLab without explicitly including those words in the script. In crafting this tutorial, ensure you are speaking in an instructional and engaging, yet friendly and approachable manner. Your voiceover will set the pace and tone for this educational experience. Remember to not merely list the instructions, but to creatively weave them into a seamless, dynamic tutorial narrative. Your performance will make or break how effective the tutorial is. A well-delivered voiceover can inspire learning enthusiasm, so make your voice your best tool in conveying knowledge. Begin immediately.